All right. Page 22. Yeah, it's page 22. Let me just go through real quick. Want to make sure that we are comfortable with problems where we have to gather information from a graph and not from a table. So for 19, which you guys have the homework, go through product rule, right? F prime G plus F G prime. You replace all your X values with 1. And then from the graph, you're either pulling the order pair, if it's G of X or F of X, or you're asked to find derivative, which from a graph perspective, it's a slope. So for instance, F prime of 1 is asking for the slope of the F graph at 1. You know that this line is going to have the same consistent slope all the way through. Just find 2 convenient points, rise over run. Sorry, for F of for G of X. Our G of X is up 2 over 1. So that's why G prime of 1 gets replaced with 2. F prime of 1 is asking for the slope of the F graph at 1. Just pick any 2 convenient points since it's the same slope all the way through. I go down 1 over 2, so negative 1/2. So just want to make sure that whether it's a table or whether it's a graph, that we're comfortable pulling information about either the slope or the order pair. Any questions from the homework that you want me to go over with you? Okay, so this is the last section before we do our quiz review. So if we can turn to page 27. All right, so we need to be able to, well, we've talked about sine and cosine's derivative, but we also need to be able to arrive at the other trig function's derivative. There are ways to derive these other derivatives using just sine and cosine, but I'm just going to have us memorize them, these 6 here. So I like to organize it in this way where I think it's nice. If you organize it in these 2 columns, there's some nice patterns that you can see, and hopefully those patterns can help you remember these formulas. So we have sine, tangent, and secant lined up on the first column. And the second column, you have cosine, cotangent, cosecant. So basically all the C functions are going to be lined up in alphabetical order. So COS, COT, and CSC. Sine and cosine just involve each other. So sine is cosine of X, and cosine is negative sine of X. Okay. All right. So the ones across from each other are always going to have a similar form. Okay. For tangent and secant, they're just going to involve each other in terms of their derivatives. So tangent's derivative is just going to be secant squared X. Likewise, cotangent's derivative is just going to involve, cotangent and cosecant are just going to involve each other for their derivative. So if you follow the similar pattern, it's going to be negative cosecant squared of X. So this is what I'm talking about in terms of similar form. Both are going to be a trig function squared. And then secant is going to involve itself and tangent above. So secant is secant X tangent X. And if you follow the same pattern here, it'll be negative cosecant X cotangent X. The nice thing about putting it in this form is that all the C functions produces negative derivatives. So that's also a nice pattern to hopefully help you make it easier for you to memorize these formulas when there's all these patterns that come across these 6 functions. Okay, so today we're just going to practice building the derivatives for each of these trig functions. All right, so let's start with number 1. Number 1 says find the derivative of sine of x times tangent of x. We see that these are 2 separate functions that are being multiplied. So we can't just do sine's derivative and tangent derivative separately. We have to go through what? Product rule. Yeah, so sine x, tangent x. We have to build out our product rule. And then once we know what we need, we can just put it all in the right place. So sine's derivative is cosine of x, yeah. G, we don't change. F, we don't change. And tangent's derivative is secant squared, yeah. This is fine. I just want to show you that sometimes if it's multiple choice, they may go a little further. And what I mean by that is that they may sometimes try to combine trig functions together. So you know that you can rewrite every trig function as sine and cosine. So tangent can be written as sine over cosine. So technically, we could clean this up and make cosine tangent to be just sine. So we could reduce that y prime to be sine of x plus sine of x secant squared x. I'm just doing this to show you how a multiple choice question could go further than this, but you know, if it's free response, this is fine. All right, number 2, find f prime of pi over 6. So this is asking to find the slope at pi over 6 for whatever this curve looks like, or at the point for this curve. So 2-step process. We first have to find f prime of x, and then we can plug in pi over 6. But to get to f prime of x, we have to go through what? Quotient rule. Yeah. So see if we can set up quotient rule. Try that first, and then I'll follow up with the steps. Okay, rely on your unit circle knowledge. You can leave your answer unsimplified, but you have to at least get down to the unit circle value. Um, so um, so here's my f prime with the pi over 6 plugged in, but we got to go one step further. We have to get it down to their unit circle values. Secant is the reciprocal of cosine. You know cosine pi over 6 is root 3 over 2, so just flip it to get 2 over root 3. Pi over 6 will stay. Secant pi over 6, also 2 over root 3. And then tangent pi over 6, we know it's going to be sine over cosine, so 1 over root 3. And this is sufficient. You don't have to go through and clean this up. As long as you have a numeric version of the answer, that would be considered sufficient. But if you just leave it in this form, this is not far enough. We got to at least get to this point before we stop. Okay, next page. Let's try number 8. Number 8, we're asked to find the equation of normal line and tangent line. So let's do the tangent line first. Page 28, number 8. Tangent line is easier. We can just find the derivative, find the slope. Normal line just means perpendicular slope. So after we find the tangent line, we can just do the opposite reciprocal to get to the slope of the perpendicular line. You know, secant is related to cosine. Cosine of pi over 3 is 1/2. You flip it, you get 2. So the slope, tangent line, we're going to keep the same slope. For the normal line, we're just having to make an adjustment with the slope. So how can I get it into the perpendicular slope? -1/4, yeah. Same point though. All right, let's go down to number 16. Now we're just going to put all of this together in terms of all, so the derivatives that we've seen across the last few days. So number 16, find the equation of the tangent line. So build your derivative. See if you can recall the derivatives of each of these terms. And then plug in 0 to get the slope. plug 0 into the original function to get the order pair, and then point slope form. Okay, go ahead and try 16 first. So e to the x stays as e to the x. Sine becomes negative. Sine becomes positive cosine, and then x squared becomes 2x. So, I found the order pair first, and then I found the derivative. And then once I have the derivative, I plug 0 into each of the x's for my derivative. Anything raised to the 0 power is going to be 1. So 1 times 4 is 4. Cosine of 0 is 1. 4 minus 3 plus 0 is 1. So I have my order pair, have my slope, my slope form. Okay, page 29. I want us to look at number 2. Does anybody still need to look at 16? So number 2, what does this remind you of? What does this look like to you? The limit definition of derivative, right? So we're actually not going to work this problem out. We're just going to try to understand what this is asking for, right? This is basically asking for the derivative of some function. If we can figure out what this is asking for, we just rely on our normal rules to get to the derivative. So we know this is asking for the derivative of something. If you had to guess, what function is it referring to? Okay, but what function is this? Are we starting off with? Cosine, yeah. So all the pi over 3 and pi, that is just within the limit definition. But we should be able to look at this and understand. Okay, it's referring to some function, and the function that we're referring to is cosine of x. But it's asking for the derivative of cosine at what? So this is our goal. Our goal is to find f prime pi over 3. So we're not working this problem. We just understand, oh, this is the limit definition of derivative. They just want us to be able to pull what they're referring to, what it's trying to ask us to do, and then we can just rely on our derivative rules to get to our answer. So this is more of a conceptual thing where, oh, it's just asking for the derivative of some function at a point, and I just have to get to this. Now I can just treat it like working at this problem. This is my new starting point, now that I know what this is asking for us to find. So let's find f prime first. What's cosine's derivative? Cosine. Now we can just plug pi over 3 in. Okay, let's look at number 5. Number 5 seems tedious, but I just want to show you how we can do something like this. Maybe we haven't talked about this notation yet, but do you know what d over dx, what does that represent? Yeah, so if you see d over dx, that just means find the derivative. Do you know what that 50 represents? So far, we've only talked about the first derivative, right? First derivative, and then, but then if we find the derivative again, it'll be the second derivative. And so this is the what? 50th derivative. And it's like, wow, like that will take a long time to do. But I just want to show you that there is a pattern that's going to keep repeating itself after a couple of times. So just want to have us discover that. So if my function was sine of x, what's f prime going to be? Let's just do the first few just so that we can see when we discover our pattern. Cosine of x, okay. That's the first derivative. Second derivative, what's cosine's derivative going to be? Okay. Okay. Third derivative, what do you think negative sine becomes? Negative cosine. And then after we get to the fourth derivative, we don't use the apostrophe anymore. We just use a number. So the fourth derivative will come back to what? Just sine, because cosine becomes negative sine, but the two negatives becomes positive. So now we're back to sine. So there's a cycle, right? Every fourth derivative is going to go back to the original function. So basically, we just have to figure out how many times does 50 cycle through the four derivatives before it settles on either one of these four. So the easiest way to do this is just basically divide by 4. Okay, if we divide by 4, we'll know how many full cycles it's going to go through, and then we should look at the remainder. The remainder is going to tell us where it's going to end up landing when it's finished all the cycles and then gotten to with whatever remainder. So your first derivative is basically the result of, if it's remainder 1, it'll land on cosine. If it's remainder 2, it'll land on negative sine. If it's remainder 3, it'll land on negative cosine. And there's no remainder 4 because that means that number is divisible by that number by 4. So there's no remainder 0. It will just go back to sine. Well, sorry, yeah. So remainder 0 would be just the original function because it's completed all of the cycles. So 4 can go into 50 12 times with a remainder of 2. So it's going to complete 12 cycles of going through these 4 derivatives, but then it's going to finish all the cycles and it's going to end at the second one. So we know it's going to end at negative sine of x. So we're not actually, doing all 50 derivatives. We're understanding the pattern and then just jumping to the end after we know how many times it's completed the cycle. Okay, let's see. Hey, I just want us to do a preliminary try to memorizing these formulas. You know, if we don't get it all right, it's fine. I just want us to at least attempt it, you know, now that we see the pattern. So if you can just find any empty space that you can, either in your packet or on a separate sheet. And let's just write out these 6 functions in this pattern. So just spend a minute looking at the rules and just seeing if you can, recognize the patterns, and then cover it up, and then attempt it to see how you do your first time through trying to memorize it. You know, if you don't get everything right, it's okay. We still have, a few more days to get it all under our belt. But I think it's just nice to at least attempt it to see where we are. Okay, ready to check your answers? All the derivative rules are in front of us. We just have to know which trig functions to merge or combine or put together to produce the derivative. So, okay, we have a little over 10 minutes. I would like for us to get started with our homework. Page 25 through 30. It's just the odd numbered problems. So go ahead and start. I'm going to start putting the answers up starting on page 25, and then seeing if we can get through a good chunk of it in 10 minutes. So just the odd number problems, page 25 to 30. Guys, sorry, page 25, skip number 3. I don't really like that problem. That's a little, I don't think we need to do something like that. So in place of 3, can we do 2? So let's do skip 3, but do 2, but then everything else being odds. So do 1 and 2 and go back to being odd problem. Let's skip 3. I'll show 5 in a second once everyone is ready to move on. So number 2, we have to go through quotient rule to get to the derivative. Plug 3 in to get the slope. I put it into point slope form, but realize that the answer choices are all in general form, which means without fractions. So I multiply everything through by 3 to allow that denominator 3 to go away. So if I distribute a 3 through, I can get all the coefficients to be integer values, and then I'm just rearranging to get it to match one of the answer choices. Again, when you go through quotient rule, just be aware that you're largely not gonna do anything with your denominator. So you gotta try to avoid that temptation to want to cancel out, right? You never want to cancel out for a quotient rule. You're just distributing and cleaning up the numerator and don't even FOIL out the denominator. That denominator squared is usually the better form to be in for whatever you want to do next. So don't try to expand that denominator. Leave it in factor form. Okay, any questions with 1 or 2? All right, try number 5. Number 5, that d over dt, that just means find the derivative. We do have to rewrite those terms. Some of those terms, we want to apply power rule for all those terms, but some of those variables are out of place. So bring all the denominator variables up that needs to be brought up, and then go through power rule, and then plug in the 2. Page 26, I'm looking at the odd number problems here. I don't like number 9. So for 26, page 26, just do 7 and 8 and replace 9 with 8. Again, on page 26, just do 7 and 8. Don't do 9. Do something off with number 8. Okay, 8x plus. Okay, so tomorrow we'll begin our quiz review. So we'll have Friday and Monday to do quiz review. Tuesday and Wednesday, next Tuesday, Wednesday, I want to start Unit 3, but you're still going to have days to prepare and review for your quiz. Your quiz will be next Thursday. Okay, next Thursday. So again, your homework, page 25 to 30, just the odd number problems. Thank you guys. Have a great day.